Now, the non-ionizable part of the coordination compound that we referred as what? Complex ions or complexes. So these complexes in the coordination compounds can be classified on the basis of ligands as well as charge on the complex. These two bases that we take to classify the complex compounds, student, it is on the basis of ligands and it is on the basis of what? Complex compounds. On the basis of the ligands, the complex can be homoleptic or heteroleptic. And on the basis of the charge, it can be what? Cationic, it can be what? Anionic, or it can be what? Neutral. So let us understand one by one what are the different type of the complex can be seen. When you are saying homoleptic complex, let us understand what is the meaning of homoleptic complex. Student, homoleptic complex means what? Complexes in which a metal is attached to one kind of donor group. I mean to say, if you see this complex, let us circle the ligands. Can I say it is the ligand? Ammonium. Again, if you will circle all the ligands, you will find the ligands which are there in the complex are what? Same. So, basic meaning is what? If complex is consisting of only one type of ligands, then that complex is referred as what? Homoleptic. But if the complexes in which the metal is attached to more than one kind of, then that is referred as what? Heteroleptic complex. Can you see? Here, ammonia is acting as ligand as well as chlorine is also acting as ligand. So there are how many types of the ligands? Two. So if there are two type of ligand, then that complex is referred as what? Heteroleptic complex. Now at this side, I have taken some examples, student. Are we able to decide homoleptic and heteroleptic? In this, if you'll see, the ligands which is present is what? Ammonia. Here it is present cyanide. This is CO, carbonyl, and again what? Carbonyl. Can I say these all complexes is consisting of only one type of ligand? Since it is consisting of only one type of ligand, and that's why it is referred as homoleptic complex. But if you'll see the ligands which are present in this complex, it is more than one. H2O and Cl, more than one type. I'm not talking about the numbers. It is ethylene diamine and bromine, and it is H2O, ethylene diamine and cyanide. So this is ammonia, Cl minus, CO and CO. These were consisting of only one type of ligand. But if these all complexes is consisting of more than one type of ligands, and that's why since it is consisting of more than one type of ligand, it is referred as what? Heteroleptic complex. Referred as heteroleptic complex. On the basis of the charges, student, if you'll see, when you say cationic, cationic means the complex should have what? Positive charge. So charge of the complex, how it is identified? It is always written outside the bracket. So outside the bracket, if it is positive, it is referred as cationic complex. Outside the bracket, if it is negative, it is referred as anionic complex. And if there is no charge, then that is referred as what? Neutral complex. If you'll see this, the complex which is over here is Ag NH3 twice, and the charge of the complex is 2 plus. Similarly, if you write the complex, this is Cr Cl2 H2O4, this is 2 plus. Then this is directly written titanium ethylene diamine 3 times, and the charge is 3 plus. Are we able to find out the charge? Yes. The charges, if you'll see, the common charge is positive, 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 and since it is positive, that's why it is referred as cationic complex. In this case, if you'll see, the charge is minus. The first complex is PtCl6 2 minus. Second, if you'll see, this is FeCN6 3 minus. This is CuCl4 2 minus, and this is ZnCl4 2 minus. So if you'll see the charge over here, the common charges are, all complex is consisting of what? Negative charge. Since they all are consisting of negative charge, so they will be referred as what? Anionic complex. At last, student, if you'll see, there is no charge onto this complex. So in these all complexes is consisting of what? Zero charge. In short, we can write it like this. All, mostly these all are what? Metal carbonyl. Since the metal carbonyl have what? Zero charge, so they all are referred as what? Neutral complexes. So again, let's go back here. Complexes can be on the basis of ligands, will be homoleptic and heteroleptic. If there is one type of ligand, it is homoleptic. More than one type of ligand, it is heteroleptic. On the basis of the charge, if it is positive, it is cationic, negative anionic, and if it is no charge, it is what? Neutral. I hope you understood this part. Thank you very much.